when you don't put anything down, there's like they don't know what to do. So if you can put something down, even if you're not sure, that's always better than nothing. But for this problem right here, one of the things that we were doing last time is we're looking at the angle. We're saying, okay, here's the angle. You're right there. Relative to this angle, what would you call 15 and what would you call X? And the possible word choices are adjacent, opposite, and hypotenuse. So is 15 the adjacent, opposite, or hypotenuse?
Um, Adjacent,
It is the adjacent. How about X?
the hypotenuse.
Very good. Now look at your matching section, ordered from memory. Which of those 6 trig functions uses the adjacent and the opposite? And you typically are focusing on the 3 on the left, typically.
The cotangent.
Cotangent is opposite and adjacent. You're looking for adjacent and hypotenuse.
Okay. Secant.
All right, this is not going well. Let me pull up a reference sheet here that I think could help. Let's see if I can find this real
Oh,
quick.
cosine.
It is cosine, yeah. And sometimes the way the matching is presented, I don't think it's as succinct as this right here. Like this is your important stuff. You got to know this. And you just said it's cosine. Cosine of 16 equals what divided by what? What goes on the top, goes on the bottom. It's adjacent over hypotenuse. What goes in the adjacent position?
15.
Good. And in the hypotenuse?
Just X.
Just X. Good. Okay. Now the nice thing is like you did that. You actually did that. And then you even went beyond that and you said, okay, I'm going to multiply both sides by X.
Yeah.
And then you stopped. And I don't know why you stopped, doesn't matter now, but you were on the right track. Okay. You were completely going to get the right answer. Okay, cosine of 16 is a number, it's multiplying X. How do you undo multiplication? Let me know when you're back, ready to go.
No.
Tristan, just let me know when you're ready. I just heard maybe you're unavailable. Okay, so you got this cosine 16 here, it's multiplying X. How do you undo multiplication?
Divide.
Divide. You divide both sides by the cosine of 16. So X equals 15 over cosine 16. Do you have a calculator available today?
Yeah.
If you're going to use your phone, please don't. I'll send you a link to that. That's most scientific, or use a scientific calculator, please.
Okay. All right. What do I need to calculate?
Exactly what's written here. 15 divided by cosine 16. And if you're using a scientific calculator, you can actually enter it all at once. If not, you've got to first figure out the cosine of 16, round it to like 4 decimal places, then do 15 over that number.
I said negative 15.6.
It is 15.6.
Oh, 15, sorry.
And then we just need units, which is meters.
Alright,
Any questions on that?
no.
All right, so let's take a look at the next question here that you have. Number 9. All right, so it's really kind of the same. It's the same sort of like you don't have the angle alpha, but you still start there. And you almost assume like, well, what if I had the angle? All right. The angle alpha has a 7 and an 8, and you have to decide, is it the adjacent, the opposite, or the hypotenuse that you're given? Like, what is the 7? Is it the
I
adjacent, opposite, or hypotenuse?
think that one would be opposite,
Agreed? And how about the 8?
hypotenuse.
Good. So which of those trig functions, sine, cosine, and tangent, and I can go grab that snip again if we need. Which of those uses the opposite and the hypotenuse?
Sine.
Sine. So the sine of the unknown angle alpha, we don't know it, but we can still write the ratio. What is the opposite? What is the hypotenuse?
7 is opposite and 8's the hypotenuse.
Very good. Okay. Now you and I didn't do any problems like this last weekend. So I would, if mom were asking me, I would say, yeah, we didn't get to these. We wanted to, we just weren't able to. But to do a problem like this, it takes a little bit of work, and it's all in the calculator though. So to undo sine, you use sine inverse. To undo cosine, you use cosine inverse. To undo tangent, you use tan inverse. Do you see a pattern here?
Yeah.
So to undo sine, you use sine inverse. You take the sine inverse of both sides. Most calculators have the sine inverse above the sine button.
So I calculate that.
Yes, please. I'm gonna do the same here. So if you need help finding that button, or you're not sure, if you've done it right, I've got the answer up to check whenever you're ready.
Yeah. Yes, please. Oh, no. Would it be 0.7?
So 7 divided by 8 is like 0.875, but you have to use the sine inverse. It's got to have this -1. What kind of calculator are you using, if you don't mind me asking?
None.
None. Well, how are you doing the calculations? Help me out here.
Looking it up.
Okay, let me drop this in the chat here.
Yes, please.
All right, sorry, maybe I didn't hear you earlier. So if you
Alright,
use
so I
that
got one right here.
calculator, well, the nice things about this calculator is you can just type it the way you see it. Now, in terms of where the sine inverse is, it's under func for function,
Yeah.
and you can see it's right there. So please go ahead and enter this and let me know what you come up with.
61.
61 degrees, you got it. So having the right tool makes the job a lot easier, and you've got the correct answer here. Okay, so let me know what you need to get down as far as notes before we can move on to the next question.
Alright. Yeah, I have all that.
Fantastic. All right, so question 8. All right. Did you have something written down that I can't see because you got +1 on this one?
No.
Well, that was very kind of your teacher. Okay. Most calculators do not have a cotangent button. Okay. They just don't. So you might be wondering, well, how can you even do this? Well, cotangent of an angle is really 1 over the tangent of that angle. And every calculator does have a tangent button, every scientific calculator. So to do this problem, you have to write 1 over the tangent of 83.7. So go ahead and give that a try, please. Let me know what you come up with.
I got 9.
No way, no way. What'd you get? Did you put this in exactly the way it's written? It's tangent, not tan inverse. So like it'll look
Yeah.
like this in the calculator. I know
Yeah.
sometimes there's just an issue with just entering it correctly.
Uh, uh, the 83.7, like the number in.
Yep.
Okay. Uh, point 11 or 1.
1104.
Yeah. Okay.
All right. Any questions on that? We're gonna do more of these when we get through everything just to review, but if you have any short questions.
No.
Okay. All right, number 10. Okay, to do this problem, you need what's called a reference triangle. And I'm going to draw this reference triangle. So the 30-degree, the side across from the 30-degree is called the short leg. And the hypotenuse up here ends up being double the short leg. And then down here at the bottom, it's x √3 for the long leg. Now, I don't expect you to memorize this, but have you seen this? Have you seen this before?
No.
Okay, that's not good. The idea is that if I give you the short leg, you can find the hypotenuse or by doubling the short leg. So this C over here is 2 times 5.
Oh, yeah. Yeah, I remember doing that in geometry, but
Okay, maybe just you know, who knows? Doesn't really matter, but that's good. I'm glad you said you've seen that before. All right. To find the other side, the long leg. Okay. You just have to multiply by square root of 3. So you literally just write, I mean, it seems, it doesn't even seem like you're doing math. You just write 5 square root 3.
And that's the answer.
That's the answer. There's actually nothing more to do there.
Uh,
It's almost like magic. It's like, what do you mean? So to prove that this works, it's not really a proof, but if you were to square 5 and you were to square 5 square root of 3 and you were to square 10, this would work. This would work here. So this is 25 plus 5 squared is 25, square root of 3 squared is 3 plus 75. Does this equal 100? And it does.
okay.
All right. So nicely done here on that. So let's go to 12. Do you, I guess I should clarify, do you still get some correction points for 12, even though you've got 3 of the 5 points?
I mean, yeah, it's probably, it's most likely worth like 4 points or something. So I'd still get a half point. So
Okay. Well, we got time. Let's do it. All right, really good here. So the you correctly found the hypotenuse was 8 square root of 2. That's necessary and perfect. Okay. The cosine of A, like you wrote, is 8, the adjacent over 8 square root of 2. And like you wrote, it's 1 over the square root of 2. Now we didn't emphasize this, and that's maybe on me here. I didn't talk about what's called rationalizing. And they really mean rationalizing the denominator. Okay. And that means to get rid of the root in the denominator. All right. So to do that, you have to multiply the top and bottom by the square root of 2.
wouldn't that just make like switch the spots, like put the
Kind
square
of,
root on
yeah.
top?
Square root on top, but then what is square root of 2 times square root of 2? Square root of 4.
Hmm.
Square root of 4 is 2.
Okay.
So, that little bit is what the teacher was looking for the final, point or two for that.
Okay.
So let's go to the next one here. Number 13. All right. All right, so for problems like this one, I like to make a little table to show my answers here. There's 3 angles. There's R, there's S, and there's T. And we actually know some of this. Like we know that R is 72 degrees. We know that T is 90 degrees. That's what the square there means. How can we find angle S if we know the other 2 angles of the triangle?
I have no idea.
What do the 3 angles in a triangle add up to?
Oh, 180.
180. So you can subtract these from 180. So go ahead and give me that other missing angle, please.
18.
18. Very good. Now we do have to find some sides. We know that little r, little s, and little t. We are given that little t. Little t is across from big T. Okay, so we know that that's 15. All right. So is that okay? We're just kind of building the table. We only have 2 more values to find.
Yeah.
All right. So you got to pick an angle. Do you want to pick angle R, or angle S?
R.
Okay. So starting up here at angle R, let's find S. So what is S relative to angle R? Like, is it the adjacent, the opposite, or is it something else? Adjacent, opposite, or hypotenuse?
Adjacent.
Is the adjacent, and you have the hypotenuse. So which trig function would you use in that case?
Cosine.
Yes. So cosine of 72 equals the adjacent, which is S over 15. How do you solve this for how do you get rid of that 15 in the bottom?
You multiply.
By 15 on both sides? Yep, that's correct. So go to your calculator. 15 times cosine of 72.
.6.
Let's go 4.63.
Okay.
Okay. So we're almost there. We got only the last side, R, remaining. Okay. So when you have 2 of the 3 sides, you actually have a couple of options. You can use the Pythagorean theorem to find the third side, or you can use trig again, sine, cosine, tangent, which sounds more appealing to you.
Cosine. Or
So we're gonna
Yeah.
use sine for this one. Let's do,
Trig.
so it's the sine of 72 now. If we're gonna use the same angle, equals R over 15. So will you calculate that for us, please? It's the same setup as the previous one. You just got to multiply by 15.
Yeah.
Remember, I'd never try to give you something that I know you can't do. We're not, it's not like I want to make it overly difficult. It's the same calculation, different numbers.
.2.
Yeah, maybe 2.7 or 3 would be a little better, but I wouldn't make a big deal out of it. Not like we're building a structure off these numbers. So good. Questions on that?
No. Okay.
Oh, here we go. Number 14. All right. For safety, An extension ladder should be placed at an angle of about 75 degrees with the ground. If a ladder is 20 feet long, how far from the wall should the base of the ladder be? All right, there are two kind of ways to view this problem. One is where the wall is on the right, and there's one where the wall is on the left. Which way do you see it? And there's not a wrong answer. It's just, how do you visualize this?
Left.
Okay. The angle that's made with the ground is 75 degrees. Is that angle A or angle B?
A.
It is A. So let me write that in there. A is 75 degrees. The ladder, and sometimes it's like you just got to draw a ladder just to kind of visualize it. That's the ladder, and it's 20 feet long. All right, so sometimes I do drawings and they're kind of, they got a lot going on. So it's good to even just redraw them here with that, with kind of just less stuff going on here. Are they asking you to find X or Y in the problem?
X.
They're asking you to find X. Okay. So just like we did in the previous problem, is actually less work than the previous problem. Which trig function are you going to use and why?
One of the sine, cosine, tangent ones.
Yep, you got to decide which one.
Uh, um, Opposite and adjacent.
So opposite to 75, though, would be up here, it'd be Y.
Hypotenuse adjacent.
Yes. And which trig function is that?
Secant.
Say that again. It is secant, but you don't want to use secant. You want to use sine, cosine.
Cosine.
Yes. So cosine of 75 equals what over what? What goes in the top, what goes in the bottom?
X on top and 20 on the bottom.
Okay, very good. And I'd like you to solve this like we did in the last problem. So you got to clear that that fraction, please.
Okay, uh, 5.17.
Very good. Maybe 5.18 for rounding. Now, what are the units here? You don't say, oh, it's 5.18. You always give it a unit when you're talking about
5.18 feet.
feet. Very good. All right. Good job on that. Now, just for me, for Matthew, could you also calculate the height here? And to do that, you will use sine instead of cosine, please.
Okay. 19.31.
You got it. Good job. All right. So do you have everything down for your test corrections?
Yeah.
Okay, fantastic. So I'm putting this up on the screen again. And what I want to do is give you some problems where you have to decide whether you're using sine, cosine, or tangent. These are just kind of like rapid fire problems where you have to just look at the triangle, decide which sides you're given, and then go.
Alright.
So let me throw a couple in front of you here. All right. So you don't have to calculate it. You just have to say it's sine, cosine, or tangent, but you only get one try. So please don't rush to answer it. Make sure you're solid and
Um, tangent.
you ever watched Family Feud when they have the big X that comes up on the screen?
Yeah.
Yeah. All right, let's try again. Tangent is opposite over adjacent. You're right here. It is opposite, but 17 is not adjacent.
Cosine.
Goes not cosine either. We got another double X. We're gonna send it over to the other team here in a moment. Opposite over
Oh.
hypotenuse.
Sine.
It is sine. Good. So the sine of 59 degrees equals X over 17. Okay, let's try another one here. Would it help to have these on the screen for you while you're doing these problems?
I mean, it's fine. I have it in front of me, but
Okay. This isn't to try and trick you or make your life difficult. It's just some practice. Or you'd say, okay, I'm gonna look to compare where it is. I know you don't have the advantage of like rotating the screen here, but do your best here, please, for this one.
mhm. I don't even know which one I'm supposed to be looking at.
16. So the angle's down here in there. So you gotta like say, okay, that's side
Oh, okay.
10 and then X.
Cosine.
It is cosine. Good. So the cosine of 51 degrees equals 10 over X, like this. You had a problem like this on your quiz or test corrections. Do you remember how to get the variable out of the bottom
Um, Multiply.
by the variable? Yes. Okay,
Yeah.
good. So let's do that here. Multiply by X, multiply by X. On the right side, they cancel.
Mm-hmm.
So good to kind of rewrite it here. X cosine 51 equals 10. How do you get to X? How do you undo this cosine 51?
You divide by it.
You divide by cosine 51. Could you go to your calculator and give me that result?
15.9.
It's really good. All right. Now you had an earlier problem where it said to write your answer. We're gonna have to go back and make one correction here. It said degrees and then minutes. And then there's even this thing called seconds. Do you remember that at all from in the course, seeing that before?
No.
Okay. So what I want us to do here, and I'm going to go back and grab it here. Let me grab that problem. So there was a problem and I didn't want to make a big deal out of it at the time because it was going to be really confusing. But problem number 9 here said to find your angle to the nearest minute. And it's like, what do you mean by, like, what could they possibly mean by that? Okay. Well, we ended up finding the answer to this problem. The answer to this problem was, let me just do it one more time here.
61.
Yeah, I need some decimal places. The angle ended up being 62.7. Well, let me go out 734. Okay. So we need to so you're going to want to make a small modification what I sent you. I didn't want to dwell on this, especially if this isn't something that you're going to see all that much of. The angle in degrees, the degree part is 62. Okay. To get the minute, you have to kind of follow a process here. So to get the minute, you first take that 62.734 and you subtract 62. So basically you just get the decimal part of it. And then you multiply by 60. And the reason is there's 60 minutes in an hour. It might seem silly, you know, I don't know why this is still done, but this is the case. And this ends up being 44 minutes. So the little addition you want to make to your number 9 is to change your answer to degrees 62, minutes 44.
All right.
All right, so let's look at a few more problems here. A couple other things I noticed from us working together here. So let's say you get an answer like 4 divided by the square root of 2, and you're supposed to rationalize the denominator. All right, do you remember what you're supposed to multiply the top and the bottom by in this case when you rationalize the denominator?
The square root.
Square root of 2. What does the bottom become?
2.
Okay. Now you can simplify outside the root. So 4 over 2 is 2. So we got 2 square root of 2. All right, so here's a problem for you to try. 12 over the square root of 3. Could you simplify that for me, please?
Four square root of 3.
Got it. Very good. Okay. So I think the next set of problems we'll look at are these special triangles. So we already had one. We had one earlier. So I gave you a problem like this was 30 degrees. This ended up being like 8. And here's the reference triangle, okay? X, 2x, x root 3. So can you tell me what the hypotenuse is based on this reference triangle over here?
Hypotenuse 16.
16. And how about the base down here?
8 square root of 3.
Yes. Now, the other type of problem you might see is one where they give you the hypotenuse. They tell you that the hypotenuse is 10. Okay. Can you tell me what the leg over here would be if the hypotenuse is 10? Basically, you're going
5.
back 5, right? And then you're multiplying the base by square root of 3, 5 square root of 3. So the key to these problems is really knowing the reference triangle. Okay. And keep in mind that it won't always be presented like this. Like I could give you a problem that looks like this, where this is 30 degrees and this is 28. And you have to realize that the reference triangle also moves around. Okay. The short leg is always across from the 30. The X is always across from the 30. That's the short leg. The hypotenuse is always 2x. It's across from the 90. And then the x root 3 side is across from the 60, which sometimes you have to draw that in. Could you tell me the other sides of this triangle, please?
Um, I mean, 28 square root of 3 for that one, obviously, and then
No, I'm sorry. Let me be here. What's the give me the I don't know, give me this one down here. What does it become if the hypotenuse is 28? It's the short leg. How do you go from the hypotenuse on the right down here to the bottom?
14.
Yes. And what does the long leg become?
14 square root of 3.
Very good. So what you have to do when you're looking at a problem like this is you have to decide. You have to decide: are you given are you given the hypotenuse, the short leg, or the long leg? So here's a new problem. I want you to decide: are they giving you the short leg, long leg, or hypotenuse?
Short leg.
They are. So I'm going to draw in the reference triangle for you, but at some point you have to have it down and be able to sort of rotate it around. If this is 30, that's x, that's 2x, that's x root 3.
8 and 4 square root of 3.
Which is 8? Is it A or B?
Yeah.
A is 8. B is 4 square root of 3. Good. All right. Nicely done. All right. Here's a new problem for you to look at. So you got to say the letter, you got to say, okay, it's A equals, or in this case, it's X equals Y equals.
Y equals 6 and x equals 6 square root of 3.
Really good. Really, really good. All right. So occasionally they give you a problem like this where they give you the long leg. They tell you that the long leg is like 10 square root of 3. And they want you to find, I'll just say A and C. So to do this, you have to always refer back to the reference triangle, x root 3, x and 2x. And you have to say to yourself, oh, they're giving me the the long leg. The long leg is x squared to 3. So you actually set the known side equal to the reference side.
Okay.
And then what does x become in this problem?
10.
10. So that means that A is really 10, and what is C? How do you go from the short leg to the
20.
hypotenuse? It is 20. Very good. All right. Well, we did it. We got done with the lesson and we got your